So today we're going to be proving the chain rule for calculus, and we use it every time we want to find the derivative of a function that's inside of another function. So if g of x is inside of f of x, then we would get f of g of x. Then in that case, if we want to find a derivative of it, then we would use the chain rule. I'll remind you that the definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So if we let y equal to f of g of x, and we use the definition of a derivative here, then let's set up our equation for dy dx, which is our derivative. So dy dx is equal to the limit as h approaches 0 of f of g of x plus h minus f of g of x all this over h, and that is our expression. So here we're going to multiply by another term, and this term might be a bit strange, but it allows us to simplify it into something a lot nicer. So this term is g of x plus h minus g of x all over g of x plus h minus g of x. So why are we allowed to do this in the first place? Well, the reason why is that this just evaluates to 1. Both the numerator and the denominator are the same, so this would just evaluate to 1. And if we multiply an expression by 1, it doesn't change the value of it in any way. So we're technically allowed to do this. Another thing we're going to do is we're going to swap the denominators. Why are we allowed to do this? Well, if we're doing 2 over 3 times 4 over 2, technically we're allowed to swap the denominators and make it 2 over 2 times 4 over 3. And the reason why we're allowed to do that is because we're multiplying the numerators and we're multiplying the denominators, so it doesn't matter what order we do it in. So with that, let's set up our new equation. dy dx is equal to the limit as h approaches 0 of f of g of x plus h minus f of g of x all over g of x plus h minus g of x multiplied by g of x plus h minus g of x, and all this is over h. Okay, so now we have this expression. So this looks like some crazy limit, but if we split up into two different limits, it might be a bit easier to see. So dy dx equals to the limit as h approaches 0. We're just going to split in half here, of f of g of x plus h minus f of g of x all over g of x plus h minus g of x, and we're going to multiply it by the limit as h approaches 0 of g of x plus h minus g of x all over h. Okay. So on the right here, something you might notice is that this looks an awful lot like the definition of a derivative, just with g of x instead of f of x. So all this entire expression here just evaluates to g prime of x. So that's great, but what about here? This long expression, what does this evaluate to? Well, let's make a substitution here. So let's let k equal to g of x plus h minus g of x. Now, because we're working with limits, we also have to see what happens when h approaches 0 to k. So when h approaches 0, so this disappears, we get g of x minus g of x, which is just 0. So one thing we have to note is that as h goes to 0, k also goes to 0. What else can I do with this? Well, I can add g of x on both sides, and I can get k plus g of x is equal to g of x plus h. So we have two substitutions we can make, and we have our change of limits. So let's rewrite it. dy dx is equal to the limit as k goes to 0, because if h is going to 0, k is also going to 0. So k goes to 0 of f. So instead of writing g of x plus h, I'm going to write g of x plus k, because that's our substitution. So g of x plus k minus f of g of x. And so for the denominator here, we're going to use our substitution that g of x plus h minus g of x is equal to k. I'm just going to replace this entire thing with k. And that's our new limit. And we're going to multiply this by g prime of x. Now, this entire thing, that just looks like a definition of a derivative here. You can see up here, it's the limit as h approaches 0 of f of x plus h minus f of x all over h. This is the limit as k approaches 0 of f of g of x plus k minus f of g of x all over k. So this just evaluates the f prime of g of x. And since we're multiplying it by g prime of x, we end up getting our derivative. So dy dx is equal to f prime of g of x times g prime of x. And that is the chain rule.